For example, let me say not a discrete random variable. Let's say a continuous random variable. You have your mobile phone. You move in the city, and the signal strength which is you are receiving at your mobile phone, it's random.
Mm-hmm.
Why it's random? Because it depends upon the tower, the mobile tower which is transmitting the signal, and it also depends whether you are in a direct line of sight or is the signal is coming after reflection from different buildings. So it means it's a random variable. Uh, It's not a discrete, it's a random because that thing, it's a continuous random variable. But this is that's one example that could you see, right?
So the output is dependent
On
upon.
a random experiment, or it's dependent
Yeah.
upon so it's not something which you can say um, is like if I say, let me say 3x plus 5 is equal to 9. Do you see that this equation on your screen?
Yes.
Okay, this x is not a random, it's a fixed, it's a variable. This x, you can find that it would be 3x is equal to 9 minus 5, and then it is 4, and x would be 4 over 3. Yeah, but
Yeah.
this variable
Yeah.
value is not dependent upon a random experiments. It's a fixed value.
So when it's on if there's a probability attached to it, then it's a
Yeah,
random
yeah, yeah,
variable.
then it's a random variable. Yeah, so it's
Yeah.
whether it's discrete, for example. Yeah, so if I mean if I roll a normal dice, what is the number at the top? It could be 1 or 2 or 3 or 4. So it's a discrete random variable, and normally we write discrete random variable with I like write like this. If I write this small x, yeah, so
Mm-hmm.
it's a number. If I write like this, it is a random variable. Do you understand? And if I throw a dice, so what values you can have? You can have 1, 2, 3, 4, 5, 6. So if I say probability that your random variable would be having a value 3,
Mm-hmm.
yeah,
1 in 6.
yeah, it's 1 over 6. And if I say, okay, now I change it to another thing, we are going towards Ludo, and our output is the success. Success, when is the success? When we have,
6.
yeah. So what is in that case in Ludo, probability of success and probability of failure? Let's say failure means you don't have a 6.
Yeah.
Can you
The
help me with?
probability of success is 1 on 6. Probability of failure is 5 on 6.
Very nice, very nice. So what we have done now, so we are actually moving towards our today's topic. So what we have done,
Mm-hmm.
if the output of the random experiment is binary, binary means just two, and they are mutually exclusive. Do you understand? So I'm
Mm-hmm.
taking two things. What I said,
Two things
uh,
that don't relate to each other.
the two outputs, not. So I would write it for you so that you are not confused. So if there is just two outputs, once has a two outputs, it means there is just two, like a success and a failure. It's a binary, yeah,
Yeah.
and it's exhaustive. Exhaustive means you do not have any other thing. For example, if I say the previous example of a dice where we said we can have 1, 2, 3, 4, 5, 6 here, and everything has a probability of 1 over 6.
Yep.
So how many outputs are there now in this case?
6.
So it's not a binary output, right? So it's not binary
No.
means 2, right? So one is,
Mm-hmm.
and then they are exhaustive. Exhaustive means they are mutually exclusive. Mutually exclusive, what does mean? If one happens, the other doesn't happen. If you are getting a 6, you are not getting any other number like 1, 2, 3, 4. Mutually,
Like they don't relate to each other.
no, they
They're
relate to each
opposites.
other. But if one's happen, the other doesn't happen.
Like heads or tails are
Yeah, head or
mutually
tail.
exclusive.
Yeah, mutually exclusive. So they are And exhaustive means there are no more outputs. Yeah.
Okay.
So then it is a Bernoulli random variable. Do you understand? So let me write it,
I
and you
think
would.
so, yeah.
So let's say what is Bernoulli. Um, Let me write a little definition of it. So I say
Mm-hmm.
a trial which can be considered to have just two mutually exclusive and exhaustive outcomes, sometimes referred to as success and failure, is called a Bernoulli trial. Do you understand, or should I type it so that we can discuss this?
Um,
I better type it, yeah?
yeah, I think it's better if you type
Okay.
it.
A trial, trial which can be considered to, let me have it a little bit, which can be considered, okay. Mhm. I just remove your, so a trial which can be considered to have just two mutually exclusive, and you understand what is mutually exclusive.
Yes.
Mutual means both, exclusive means
Mm-hmm.
if one happens, the other doesn't happen, right?
Yep.
And exhaustive means you have just these two outputs, or just two mutually exclusive and exhaustive outcomes, yeah, or output. I say output or outcomes, yeah.
Yep.
It can be sometimes called as success and failure. So one is success, one is failure, because, right? Like I said, if we throw a dice, six is a success and any other number is a failure.
Okay.
Yeah. This is called Bernoulli. Let me make it a little smaller, and Bernoulli trial. Do you understand that?
Trial which can be considered to have just two mutually exclusive and exhaustive outcomes is called Bernoulli trial. Yep.
So it
So
means
there's
if
only
we
two
are, yeah, two
possibilities.
possibilities. So it's, for example, it could be a dice throw can be a Bernoulli trial because it has one success. But once we say, then we are saying, let's say head is a success and tail is a
Okay.
failure. Then we can say it is a Bernoulli trial.
Okay.
You are you have gone to or in there are many other things where you see, for example, like there is a in casino there is some type of a roulette or something, and if particular number comes, it's a success, otherwise all are failures. You understand that?
I think so, yeah.
Yeah,
So
okay, so we understood.
basically two events.
Yeah,
One event is a success, one event is a failure.
yeah, and
Okay.
they are mutually exclusive, and these are the only ones, right? Okay, so that's now we can make it in another way. If we can do it in another way, we can say it like uh, let me move it how I should. uh, Okay, I just make a small it. Yeah. And so I move this thing a little up, a trial. Right. Okay. Um, so if I should do like this, I make a small table for your understanding.
Mm-hmm.
So we said there is one, let's say we say it's one failure, and we say one is success. Yeah. And let's say
Yep.
we express the failure with, and we say x, small x. It's not a big X. The big X would be a random area, 0 and 1. And I then put like this and other. rho and say I say probability of x is equal to this x. Can you help me with the, if I consider that this is a dice, can you help me writing the probabilities?
Yeah. So what would be the success?
So you tell me, if you play Ludo, you know success would be once we have a dice which comes out six only, and the other are all failure.
Six.
So what would be the
So
probability of success?
1 in 6.
And so one and six. And what about the failure?
Failure 5 on 6.
Yeah. So we understand that, right? And we can do
Yeah.
like this, and a very interesting thing also. If the probability, now we generalize it. I give a concrete example of dice so that you understand, but because we are actually learning generalized thing. So if it is P is probability of success, what would be the probability of failure? 1 minus P.
1 - P.
Yeah, that's so we would remember this for a Bernoulli
That's the
trial.
general rule
Yeah,
for
that's a general.
Bernoulli trials.
Yeah, 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 yeah. So we would take this example of dice to do something more. Yeah. Okay. Let's say you have a. Let me ask you. Let's say you have a test, and in test there is MCQs. Every MCQ has four answers, and there is just one correct answer. What would be the
Mm-hmm.
probability of success? And what would be the
1 in 4.
1 in 4? And what would be the probability of a wrong answer or a failure?
3 on 4.
3 on 4. Good. Yeah. So we understand that. That's good. Now we come to something which is called expected value or the average. What does it mean?
Mm-hmm.
If means if you do this Bernoulli trial repeatedly, what would be your average? It is called, so we normally write like this: E is expected value, it is, and then we write
Mm-hmm.
this as a random variable, which is a Bernoulli random variable. What does it mean? It has just only two outcomes, right? So
Yep.
this is written as xi, which is smaller. Remember, I'm making this x, once I'm write like this, which is a bigger one, it is a random variable. Once I write a small x, it is the outcome. Does it make sense?
Yep.
Okay.
Yep.
Xi dot means multiply with pi. Is it somewhat clear or no? This
So
is
the sum of the answer multiplied by the probability.
yeah, outcome. So what does it mean? So let's look at
Outcome.
this example of our dice, which is we are sending, and we said so xi is failure. The failure is 0, and the
Mm-hmm.
probability of it is 5/6. So we would
Five
say
on 6.
0 times, and I'm putting a dot for multiplication. You know that instead of writing a multiplication sign, and
Yeah.
then plus 1 dot 1/6. Do you understand that?
Mm-hmm.
Okay. And then it would be how much? The answer is
1 on 6.
1/6. And that brings us to a very interesting thing. What in case of a Bernoulli trial or expected value is actually what was your 1/6? It was actually the probability of success. So
Average.
no, a-
Yeah.
the average is, but it is actually your probability of success. 1/6. If you look at here.
Ah.
So we are
And that's
making a
for all
generalized.
Bernoulli
I,
trials?
I am what I'm trying to do. I'm trying to first give you a very specific example and trying then making a generalized.
Okay.
So as we learned earlier, that the probability, if the probability of success has P, the probability of failure would be 1 minus P. Similarly, we have now learned
Mm-hmm.
that the expected value of a Bernoulli trial would be actually the probability of success.
Is there a proof for that? Like, why does that happen?
Sorry, say again, please.
Why is the average just the success value? Is there like a proof for that, or
Yeah, it's something I think which is calculated, but in your text, only if you what I understand, you are asking how comes this formula came, this where I have put a arrow. Yeah, but at the moment,
No, I was wondering why, how, like, what's the reason that the average is just a success value? What's like the proof behind that, or the
we
reason that
did that.
happens?
We did that. We there is we understand that. Why? One is failure. So do you understand this formula? Let's take this for granted. The expected value of a random
Yeah,
failure is actually the sum of the outcome times its probability of the outcome.
yeah.
Okay. And now this is a generalized formula for, and now we have one output, one outcome which is a failure, and the failure is represented by zero, and the success is represented by one. Therefore, anything multiplied by zero would become zero, and you are left with one multiplied by the success probability, which therefore you will always have P.
So why do we take failure as zero and success as one?
Give me another suggestion.
If we do, oh, I guess it doesn't matter unless if we do one and two, so failure is one, success is two, or failure is one, success is three. Does that change the outcome?
Yeah, certainly, certainly, because they have to be opposite to each other. I mean, if it is black and white, like we see in binary numbers, one is zero,
Mm-hmm.
one is one, zero and one.
So to keep
If there
it
is a binary,
mutually exclusive,
yeah, they have to be mutually exclusive.
yeah, okay. So to keep it mutually exclusive, we use zero and one.
One,
And
yeah,
because
that's
when you're doing
important.
average,
Otherwise, if you are using two and three, they are not mutually exclusive. You have pointed out
yeah,
very correctly. Therefore, we were saying here, they have to be mutually exclusive. You, you,
okay.
you got it. You got it. Okay. So we
And then
understand
because
that?
it's multiplication,
Yeah,
it ends up being p because it's zero and one being
yeah,
multiplied by the respective values.
yeah. So we also sometimes write 1 minus p as q.
Okay.
What does it mean? It is the probability of failure because
Yeah,
P is so some if you get across Q, don't be confused. It's just another way of writing. Okay,
a failure.
yeah, failure. Sometimes in some books and sometimes it may be written like Q. Okay,
Does it
now
come up in exams as q?
it can, it can,
It can.
yeah. So
Okay.
just remember that 1 minus P is Q.
Okay.
Okay. Um, so we have now understood why we are actually your question. Let me rephrase your question. Why we are saying it's an expected value? Why are not we saying it as an average?
Is it uh, um because we expect like that's the trial we want to happen?
No, if we have fixed number, like I said, 2, 1, 2, 3, 4, they
Yeah.
are we can do an average. Average would be x bar is equal to 1 plus 2 plus 3 plus 4 whole divided by 4, right? And this would give you an average. But here,
Oh, we don't divide because it's a probability.
but here, in this case, no, we are saying expected because this 4, this 3, this 2, in case of a probabilistic, is not definite. So what we are saying, we would do this experiment many times. And that's, we would say, that would be the average or expected value. Therefore, we do not use the word average, we use the expected value. Again, let me
Could
give
you
you an
repeat that,
example.
sorry?
Let me give you an
Yes,
example.
please.
Again, of mobile phone. On the mobile phone, you have a signal strength. And if you move in a city or at any rural place, that would be will it be the same? No, it may be even dependent upon the weather, because the weather also affects the signals which are received by your mobile phone. So it means the signal strength which you are receiving is actually a probabilistic. It is not a definite one. And therefore, if you say, I have to take an average, you can't take an average, but you need to have an average. Why? Because if your telephone company wants to give a good service to the clients, to the customer, they would like that at least there is that much signal strength on everyone's customer's mobile phone, so they are able to communicate effectively, they are able to talk, or they are able to use the data effectively. Do you understand? So they have to design it. And but the signal strength which is being at the receiver or at your mobile phone is a random variable. Again, it's not a discrete random variable, it's a continuous random variable. And once they are designing the network where to put this tower to transmit that energy of the signals, they have to
Mm-hmm.
they have to do some type of a math. So what I'm trying to say is it's not an average, it's expected value. And why it's called expected value? Because it is dependent upon probabilistic function. It is dependent upon probability. It's not definite. We do average once we are definite.
Yeah.
So therefore we
So
say use the word
can
expected value.
can the Bernoulli distribution, so the example we were doing before was on discrete random variables. Can it also be done with continuous random variables?
That's out of your course. Yeah, certainly. But at the moment, that's
Okay.
not in year 12. Yeah,
It's on year 12?
it's not in year 12.
Okay.
So in year 12 we have just so yeah, that's okay. We understand that. So this is your expected value, and then there is a variance. Variance means how much your value is actually, because it's an expected value. It's not going to be definite. For example, here is this average which we took in this example. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10 over 4. So I write that 10 over 4, and it is 2.5. Yeah. Now this is
Mm-hmm.
definite. But here we are saying in case of a random variable, it's a expected value and it may vary. What is the variance? So we say variance of this random variable. Again, I would put a is actually given by a formula which is called here sum of probability of outcome times xi, which is the outcome, minus expected value, and this square. And I put this bigger bracket. Let me rub it and make a bigger bracket instead of, yeah. So this is like a formula. So what we are saying, for example, do you understand this?
Could you explain it, please?
Yeah, yeah. I would explain with the example. So I would be
Mm-hmm.
explaining it with respect to 1 minus p, or, yeah. So
Yep.
it would be, it's easy. Why it's easy? Because we have just two outcomes. We are not with a lot of outcomes. We have just two binary outcomes. So for example, so if I say its output is 0,
Hmm.
okay, let me just rub it because now pi. If it is a failure, what is for this failure the probability? Look at this table, failure success.
5 on
No, no, we
6
are now
is the
making it
fail.
generalized. We are making it
Oh,
generalized.
1 minus p.
Yeah, so we would write 1 minus p, right?
Mm-hmm.
And then what is xi in this case? What is the outcome here? It's small,
0.
very nice, 0. And then minus. What is the expected value of a random of Bernoulli trial? Ex was
P.
p, very nice. So 0 minus p whole square. Yeah. Then plus, now we would take the other one. It's for success. What is the
Oh,
probability?
P.
P. And what is now we have to write 1 minus
minus P.
P whole square. All good? Now we would simplify
Uh,
this. Yeah? We simplify that. This becomes 1 minus P times 0 minus P is P. So I will just write P square plus P into 1 minus P square. Right? Are you good with that? Okay.
1 minus P squared.
1 mi
How did you get that? Sorry.
which one? I'm just simplifying the above equation. It was 1 minus P. What is 0 minus P square? So 0 minus
P
P is minus P
minus
and
P.
minus P square is P square. So I wrote it like this. And that I have just copied from the above equation, P1 minus P square.
Okay. Yep.
Should I explain again or you're clear?
No, I think so. It was just that minus P. So minus P squared is P squared.
Yeah, P square. Yeah, you are right. So that is.
Okay.
Okay. So what we can do is we can take the common because we see, let me write it with 1 minus P and 1 minus P. So we have 1 minus P common. And from here P and P square P common, right? So we can
Yep.
take P. I'm writing in red because I'm taking those. That we can take common. So what is left here? First, if we take this P1 minus P from the first
Uh,
term, we are left
we
with
get P
P. And what about next plus? And we have taken P and 1 minus
1 minus P.
1 minus P. And this 1 minus P, this P and 1 minus P and
So that's just P 1 minus P, is it?
P are very nice, very nice.
So
So
P minus P squared.
variance X is P in, and this is actually, if I see, it is actually P times Q maybe, if you are, sorry, it just changes sometimes. I will
P
just,
triangle.
yeah, it just sometimes P and it is Q. I don't, well, I don't know why. It's sometimes considered that it's, so I would be just writing like Q. So P into Q. So the variance
So the variance,
is P into 1 minus P.
isn't that just the success times the failure?
Yeah, yeah, success times failure.
So the expected value is the success. The
Right.
variance is the success times the failure.
Yeah, very nice, very nice. So you can remember like this. It's very easy. And again, this is a Bernoulli trial. It means it has just two. Yeah.
Hmm?
Okay. Now we move to the next, which is a binomial distribution, and that comes after this. So I would just write now binomial distribution. Binomial distribution. So what we are trying to do now is if a Bernoulli trial is performed repeatedly with the probability of success, which is with a constant probability, and the trials are independent, then we call then the distribution which we achieve is called a binomial distribution. Again,
I
okay,
yeah.
let's make it a very simple example. Let's say we have a coin, yeah,
Yep.
and just to make it easy and to make it more understandable, we think it's a biased coin. So biased coins means it's not zero point 0.5 and zero point 0.5. Maybe it is made like this that it is zero point 0.3 and zero point 0.7. So maybe, yeah. So let's say we have a, so there is a head and we consider head is a success, right? And there is a,
Okay.
and we say this is P, this is 1 minus P. Do you understand that? Or 1 minus P
Yep.
is Q. So, and now this is a Bernoulli trial, right? But now
Bernoulli. Yep.
we do it more times. Instead of just tossing. Once we toss is again. Yeah. Once we toss is
So we do it
again.
multiple times.
Yeah. Let's say it's two, head and tail. So this is the probability P. Yeah. And
Mm-hmm.
then it would be 1 minus P, right? Here, let's say we say it is a head or it is a tail. So this would be P into 1 minus P. You understand that? We have done it twice. Let's
Mm-hmm.
do it thrice. So we are doing a
Okay.
Bernoulli trial now multiple times.
3 times. Yeah.
It can be multiple times. We would do it for three and then we would then make the formula. We would try to have a generalized equation then. That's our aim. So I am just doing it
Okay.
thrice. But if I say it happened 8 times, so it would be a very big tree. So it would be difficult to make this tree. So therefore, what we would do, we would just try to make generalized by this. We would understand this and we would say, okay, we will try to make generalized formula for n number of trials. But at the moment, just to
Okay.
keep it simple, I would say let's make it for three, and that would help us. So what is a binomial distribution then? Can you, in the meantime, all right, can you say what is a binomial distribution?
Binomial distributions is a Bernoulli distribution, but with multiple trials.
Yeah, well, you're right. So binomial distribution is actually an extension of Bernoulli, which is the same uh, trial which has just two outcomes, one success, one failure, which are mutually exclusive, are done multiple
Mm-hmm.
times, right? That's good. Okay. So can you help me with writing this? I take another color. Let's make it. What is probability of H, H, H?
3p.
3p? You multiply them, not 3p.
Oh, p cubed.
Yeah, there is a difference between p cube and, yeah. What about now
Mm-hmm.
we move? So what is the next one? Is probability of head, head and tail.
Fails.
So what is this one?
So p squared minus p cubed.
No, p square into 1 minus p. You are following
Don't
this.
you expand that?
At
Or
the
don't you
moment, we keep
expand the
it like that.
brackets?
We don't expand. At the moment, we keep
Okay.
because we want to have a generalized mechanism.
Okay,
We will
okay, okay.
not.
Sorry, I expanded it in
Okay,
my
yeah, no,
head.
don't
Sorry.
expand it. Okay, now probability of. So this is probability of head, tail, and head. Do you see that? Head, tail, and head. So
Mm-hmm.
what is it?
P squared 1 minus p.
P square 1 minus p. You're right. So this was head, head, tail. Head, head was P, and
Mm-hmm.
we understand that. So what I would be doing is just to be head, tail, tail. Can you tell me that?
P 1 minus p squared.
Very nice, very nice. 1 minus P square. What about probability of tail, head, head?
P squared 1 minus p again.
Yeah, good. And next is a probability of tail, head, tail.
P 1 minus p squared.
Yeah, P 1 minus P square. Then we have probability of uh, tail, tail and head.
P 1 minus p squared.
P1 minus P1 minus P square. Very nice. And then is a probability of T, T, T. This is
1 minus p cubed.
very nice. So we have something like this. Yeah.
Yeah.
Okay. I just try to make probability distribution, which you must have learned during your random variables. So I try to do that, right? So what I have to do is
Mm-hmm.
probability of x, which is a smaller x, and it is 0, 1, 2, and 3.
Yep.
What we are saying is probability of random variable x is equal to x. What is the probability of first? Let me just rub it a little bit and write it in a.
So these are the probability of getting heads, right? So 0, 1, 2, and 3.
Yeah, because our success is getting ahead. So what is the probability
Yep.
of getting? So what does it mean? Zero means in the three trials
No
you had
heads.
no head. You had all tail, tail, tail.
Yep.
So what is that? Looking at your history,
1 minus p cubed.
1 minus p cube. Very nice. Now we come to probability of having one head. And there now you will
Uh,
have to be very sure what you are having. So head, head, head. It was head, head, tail. We are saying only one head. So
yep. So that's
let me take another color. I
p.
have just point out those. So one head is here. Uh,
Is it 3p 1 minus p squared?
yeah, just yeah. So tail, head, tail. This is one head and this. Yeah. So what is this now?
Mhm.
3p.
3p 1 minus p squared.
Very nice, very nice. And now we would say for 2, if we have 2.
2,
Yeah, let me rub that.
1,
I will just rub that.
2, 3.
Yeah. So it is
3p squared 1 minus p.
3p square, 1 minus p. What is now the fourth, third? Third means all heads.
P cubed.
Oh, very nice, very nice. So this gives us a very interesting thing. Now I try to make it something we have written it generalized. If I say you tried, you have a Bernoulli distribution, you did an experiment, what is the probability that you will have exactly two successes?
3p squared 1 minus p.
Once I say, if we say you have at least two successes if you have done that experiment 3 times.
Oh, 3p squared 1 minus p plus p cubed.
Very nice. If we say you have less than one success,
1 minus p cubed.
less than, very nice. So you understand now? So you are able to do now, say, if you are throwing, for example, maybe it's a golf and the golf person is trying to, or maybe maybe a basketball, and that person is to take a shot. It's a match, and the people have made on the basis of previous matches. They have the probability of success. So, for example, in the last 10, he has taken those shots maybe 50 times, and there were maybe 30 times he had a success. So you know the probability of success is zero point 0.6. Are you
Mm-hmm.
getting my? And on the basis of that, you can say if he gets 5 chances, how many there is a chance he would score that basket. Do you understand that?
I think
That
so. Yeah,
example.
I'm getting it.
Yeah, so that's because that's a Bernoulli experiment. Why? Either he buckets it or he doesn't bucket it.
Yeah, like either he gets it or doesn't. So
Yeah, yeah,
there's
yeah,
two outcomes.
yeah. So
And he's doing it multiple times, so it's
multiple times
binary,
during
not
the match.
Bernoulli.
I'm talking about once there is a foul and the person is able to. It can be even in football and in soccer, the penalties for it.
Yeah.
So you can have. So this is a very interesting thing. So they, on the basis of this, a coach would know to which player, if he knows this math, which player has a better
Mm-hmm.
chance of scoring on the basis of the past performance.
Right. Okay.
Do you see the beauty of math here?
Using. Yeah, yeah.
Okay, yeah, okay. We would just, so you understand that it's, this math is not this Bernoulli distribution, and now it has become, so Bernoulli distribution has now gone into binomial distribution. And that's
Yeah.
if that just one penalty in a soccer is a Bernoulli distribution, while maybe taking more is a binomial distribution. Okay,
Right. Yeah.
now we come to another thing which is important, and perhaps that would be our last thing to discuss. Perhaps it was easy to make this um, um, tree diagram, which we have done
Mm.
for maybe three trials. What if I say this experiment was done 8 times?
Does this
Oh,
have something to do with binomials? The triangle?
no. Yeah. That's also, but we would learn it another way. So if it is like this, we would change it. Yeah. So we would do like this, and I would just write the generalized form, and then we would see how this generalized form. Um, so let me write it. I think it would be good if I type instead of writing. I would just be a little, and oh, it's very small. Yeah, sometimes. Sorry, I would have to. Okay, okay. I would do like this. Okay, it's good. Okay, this size is good. So what we are saying is, suppose an event or trial, I would say trial. Suppose the trial is repeated n times. So for example, in the example which we did, how many times we repeated this trial?
Three.
Three. So let's say we say this trial is repeated n times, and I don't I write it, but I say it, and every trial had only two outcomes, one success, one failure. Yeah,
Hmm.
and and for each trial they are independent. The probability is p of success. I'm just making it a small. Your probability of success and probability of failure is uh, 1 minus p, which we know.
Two.
The so if we say in the n trials, in
Mm.
the n trials, I think my writing is okay, or is it bad? I should write again.
No, it's. I can read it. It's.
If in the n trials, actually
Hmm.
writing on a screen is also a little tricky. Okay, um, so in the n trial, so probability A occurring. A occurring means we have a success. Yeah, probability of
Hmm.
I would write success instead of A. Occurring X time. Occurring X times, where X is less than equal to N. So you understand in the last we said all head. So that was X was equal to N. So it says N choose X, P raised to the power X. In fact, I know you were doing the same thing once you were telling me. You were doing the same thing. I would just relate it with what we do. Yeah. So, so,
Okay.
so it means if I say we had three and we say there were two successes. Two successes mean two heads.
Two
And then the
heads.
P over two into one minus P over, uh, it was three, three minus two is one. So it is for probability that X was actually equal to 2. You remember that?
Yep.
What is 3 choose 2?
Three choose two.
Yeah.
Uh,
You know the formula?
three fact. Yeah, three factorial over three minus 2
3,
factorial, which
1
is
factorial, 3, oh yeah, sorry, yeah, you are right. Sorry, I just miswrote it wrong. 2 factorial
factorial.
over 1 factorial because 3 minus 2 is 1. So this is 3.
Yeah.
So this was 3p square 1 minus p, which was actually there.
Mm-hmm.
If I go back to here, where we said, so 3p square 1 minus p is the same thing. You see that?
Yeah.
Yeah.
Mm-hmm.
So it was 3p square 1 minus. So what we have done is, now we have made a generalized thing. You can say if it is a 8 trials, so
A choose
n would be
whatever.
8 and c would be the outcome. So you can make this type of a table which we have made just by using that.
And
So
if this was a real example, we would substitute the probability of P or the success wherever P is.
can you say again, please?
So let's take this table right here for x and the probability of x equal to x. Let's say P is equal to 0.6. So then you would substitute 0.6 in for P.
Yeah, we would put p and then we would. Let's
So
do an example.
zero.
Let's do one
So
example. It's
zero.
very good.
Okay.
Let's do. We say there is a fair dice. Fair dice means, and let's say we rolled it 10 times. I put it here. So example. So fair dice. Fair dice means what? Probability of success is?
5 on 6.
Probability of success. Probability of 1 is
1 on 6.
1 over 6. And probability of 0 failure is 5 over 6, right?
5 6. Yeah.
Yeah. Now we say we threw it 10 times. So n is 10.
Hmm.
So what would be the question is, what is the probability of obtaining exactly 3 6s? What we are saying? X is 3. So we are saying probability of X is equal to 3 successes. Do you understand this? What I'm saying? We are saying
Yeah.
we threw the dice 10 times. What is the probability that we would get 6 3 times?
Um.
So
Is it 10 choose 3 P cubed
yeah.
1 minus
So
P over 7?
10 choose 3 into 1 over 6 raised to the power 3 into 1 minus 1 over 6 is 5 over 6 over 7. Are you good? Can you use your calculator or class pad to see this? Or
Yeah, I'm doing that
so
now.
what is this equal to? Sorry,
Just give me a second.
no worries.
It is to the power of 7. Uh,
Give me just a number. Final answer.
I got 0.155.
That's correct. That's correct. So
Okay.
so it gives you that if you threw a fair dice 10 times, the probability you will get three uh, in any order, 3 6s in this 10 throws, the probability is 0.155. And naturally,
Yeah.
I try to give you another question. Uh, just your understanding. If I say that you get 5 6s, will that probability be greater than 0.155 or less? This is,
5 successes?
yeah, that should be
Uh,
less than 0.155 or more than 0.155.
Do you want me to
No, no,
calculate
no.
it or
I'm just
no?
asking your idea, your understanding. No, not doing anything. Make a guess.
Okay, probably smaller
Yeah, certainly smaller because then you are, um, yeah, it will be smaller.
because
Because
there's more
why?
like
Yeah,
heads
because
that you
1
need to
over
get.
6 will get 5 now,
Yeah.
and it's even get smaller.
Mm-hmm.
If you take a higher powers of less than 1, 0.5, and so it goes down and down. Okay, that's good. So this is now, I think we have almost covered the second chapter. There is some more things to cover, but we are finishing the time. Let me revise what we learned today. And I would take the example of this, whatever we started today. So we started with a small revision, what is a random variable and discrete random variable. So random variable can be discrete, it can be continuous, and we said a random variable is the one where the outcome is dependent upon a random experiment. So that is like throwing a dice or throwing a maybe uh, tossing a coin or maybe, as I said, a signal at your mobile recep receiver. That type.
Mm-hmm.
And then we move to Bernoulli. So let me write it here. So we said, what is a Bernoulli? Bernoulli. It is actually Bernoulli was the name of a Swiss mathematician who came up with this idea. Therefore, then this is called a Bernoulli distribution. A trial
Mm-hmm.
which has just two mutually exclusive and exhaustive outcome is called a Bernoulli trial. So that means we understood. So if the probability of success is P, the probability of failure is 1 minus P. And then we started looking at that, and we saw that in case of a Bernoulli trial, the expected value is the P. So if you do it multiple times, actually your uh, average or what the expected value would be the P or the probability of success. And we said 1 minus P would be Q. And then we also looked at what is the variance because it's a probability, so it's not getting always the one value. So there would be some variance, and the variance which you very interestingly have pointed out, it's a product of probability of success times probability of failure, P times Q or P times 1 minus P. Then if the Bernoulli trial is done multiple times, we come to a new thing, which is called a binomial distribution. And there we did a example where we had just three trials. And on the basis of those three trials, we try to come up with a generalized equation. And the generalized is 9 choose x, where 9 is the n is the sorry n is the number of trials from where x is the number of outcome, then is probability of success time raised to the power x 1 minus. And then on the basis of that, we did a very small example where we said a fair dice is thrown 10 times. What is the probability that you would get exactly three sixes during this? So that's the way we did today's lecture. What I would say is you are almost, if you look at the Sadler book, you should be able to do at least uh, three, I think, three exercises now. Yeah. Uh, let me see.
Yeah, chapter 9A
So I would,
finishes off
check.
graphs of binomial distributions.
Yeah. So 9A is, yeah. So it is something like, and then it's again, there are some examples where, and then it has just one more thing that sometimes we write with that I would also say if you write like this x, which is your um, random variable, as
Hmm?
bin, bin means it's binomially distributed, and then we write something like, let me write it generalized instead of, um, and It's n times p. Okay. Mm, variance in. Yeah. So n comma p. We write that. We say this is distributed like we do with this. If I do for the same example which we did earlier with the fair dice 10 times, we would say bin n is 10 and p was 1 over 6 because that was. So we say this. You understand?
Y- Yep.
It's a number of trials, which was that we threw this 10 times, and this is probability of yours. So that's one thing. And then again, uh, we are short on time, but I would just say, so expected value in this case, EX is n times P, not, so now previously you had in the Bernoulli's, you have P, and now you are doing n times. So expected value would be n times P. Do you understand that?
Yep.
Okay, because you are, and variance, previously you have P into 1 minus P. You remember?
Mm-hmm.
Now you are
Yep.
doing it n times n. Oh, that's very easy because now you have done n times.
So basically, binomial distributions are Bernoulli distributions, but with additional trials. So
Yeah,
that's
yeah,
where the n comes
yeah,
from.
yeah,
So
yeah,
they're just working off of
yeah,
the basis
yeah.
of binomial.
Yeah, yeah, that's because
Sorry,
we said it has
Bernoulli.
to have, and because each trial is independent of the previous trial. So, for example, if I
Yep.
throw a dice now,
Mm,
let's say 6 comes, which is a success. Next time I throw, is it dependent upon what it came earlier? No,
no.
no. So they are independent both. Okay, so you have now this, so it brings you that you can do 9A and let me see that. Is it 9B also?
Isn't 9A is graphs of binomial distributions as well?
Yeah, so it's a graph, so but it's almost the things which we have covered, and then the values from, and then you would be using your, um, and then there is something which is called binomial cumulative distribution function. Let me introduce it and then we finish. This is if you are here in this, let's say this table, and we said
Mm-hmm.
what is the probability that we have exactly two heads. So what is, so I am just saying this example where we made this tree diagram and we said it is a dice which is being thrown, and then
Yep.
what is the probability that you will have exactly two heads? I
3p squared 1 minus p.
and what would be if it is two or less? So you will have to add all the three.
So
Zero,
1 minus p cubed plus 3p 1
one
minus p
minus
squared plus
three,
3p squared 1
and
minus
that
p.
is sometime we have in your class pad something which is called cumulative distribution function. So you can have that. Look at that. CDs. Cumulative means content. No cancel. I don't know why it's okay. So sometimes it's called so it would be um, CDF. CDF is so you can have like CDF, which is a cumulative distribution function. It means it's adding the
Where is
previous.
that?
Sorry,
Where is that?
if you are either you do like this that you add them as we said, you add all
No,
of
on the
them.
class pad.
So you would there is something which is called um, binomial PDF, and it's also binomial CDF if you are adding the previous one.
Where is that though? Is that on statistics or
Yeah, yeah,
main?
yeah, on this. So you look at page 192 and and next time I would, if you are not able to do, then we would do it on. But at the moment, I hope you are now clear with this, all what we have covered today.